Hello. Today we are going to do functions. Some of this you've already seen before, but let's go ahead and refresh about what a function is before we really get into the characteristics of them. So function is a relation between two sets, A and B, that assigns each element X in set A to exactly one element in Y. So you'll see that in this description, the domain is listed out and the range is listed out right there. And then this is a mapping over here. And this mapping, you can see that 2 and 3 both go to Y, but 2 does not go to the same, a different part of set B. So the vertical line test will actually tell us in a graph whether it's a function or not. So if it crosses more than one time the vertical line, it will not be a function. So we'll just look through a bunch of examples and representations of relations and whether they're functions or not. So A, pretty simple example. It's a circle. It's definitely not a function because it doesn't pass the vertical line test. So no, we'll just say not a function. All right, this next one is just a table. So this table, if every Y value goes to every X value goes to exactly one Y value, then that is good. Typically that's if the X repeats, then it's not a function, but the X does not repeat. The Y's sure do, if you see, and that's okay, but this is a function. So I'll just write that as a note. X does not repeat. All right, this one, I don't know why I zoom in. It's such a habit. So if we're doing a vertical line test, you see it'll never cross it more than once. My vertical line's a little slanted. But this is, in fact, a function, and we're going to talk more about these functions that are considered polynomials. And I'm just going to write that as a reference, something that we're going to be learning more of. And I said function. Yeah, function there. I thought I spelled that wrong. There we go. All right, this next one with the table. This is a clear example of the X's repeat. 5 maps to not only 8, it maps to 9. So this is not a function. This one here, this next one, this vertical line that we might draw like right here or right here, you might think that will cross it more than once, but in fact, this function gets closer and closer to the y-axis, but doesn't actually cross it. So yes, this is a function, and again, I'm going to reference as what type of function this is. It is a rational. And sometimes it's called a reciprocal function too, but rational function is what I will be calling it. All right, and then this last one here, the y specifically is being squared here. That's going to tell me that if I were to solve this, I would have y is equal to plus or minus, and if I were to solve that quick, it would be plus or minus 2x, the square root of 2x plus 5, which is two different functions, and it doesn't pass the vertical line test. But most specifically looking at this equation, it's that y squared that tells us this is not a function. And the last representation I have here is the input is X, the student's ID number, and the output is the student's score, Y, the student's score on the physics exam. So that is a function. And if you know, like one student is going to have one score, right? You're not going to have multiple scores for a physics exam, right? So yes, it is a function. All right, so furthermore into some notations, we got function notation here. F of x is equal to negative 6x. And equation notation is just y is equal to 6x. So I know you might have to write some of these things in. So you write them in, and then you can always pause this if I'm going too fast, or if you want to do it yourself, and then check. So if g of x is equal to this quadratic, find each value. So this first one here, we just have a value of 6. So I'm just going to plug, kind of like we did when we found our vertex, right? I have g of 6 is equal to, I'm plugging that 6 into this function. And we'll go ahead and I'm going to use my calculator as well. Put the 6 squared plus 4 times 6 minus 24. And it looks like I have g of 6 is 60. All right. If we go ahead and do this one's a little bit different because it's an expression that I have to plug in to that function. So let me zoom out a little bit here. I got to take this and plug it into each of those x's. So I'm going to plug 5a plus 4. Well, 5a plus 4 squared plus 8 times that x, which is 5a plus 4, minus 24. Common mistake is students will distribute this 2 into this guy. That's not what we need to do. We actually need to FOIL this. So this is this binomial multiplied twice. And then I'm going to go ahead and make this distribution here. So this will be plus 40a plus 24. And then that minus 24 is going to... Oops, that's not 24. That's 32. All right, so let's go ahead and FOIL this. First, outer, inner, last. So 5a times 5a, 25a squared plus 20a. Those are the outers plus the inners. That's 20a. And then plus 16. You can also use binomial expansion if you are familiar with that to multiply that out. I'm going to just recopy this stuff down. And then we got a lot of like terms to combine. So it looks like there's no a squared, so 25a squared is there. Then I'm going to have a bunch of a's. 20a plus 20a is 40a, plus another 40a is 80a. And then I have 16 plus 32, I think that's 48. And then 48 minus 24. So just so to be sure my mental math is correct. Yes, that's 24. So this is my final answer, is what g of f of a 5a plus 4 is. Okay? All right, so again, we're going to do some more example or another example of just plugging an expression in or a value in. All right, so here we have h of 2, so I'm going to plug 2 in for n here. So that's going to be negative 3 times 2 cubed minus 3. So negative 3, 2 cubed is 8 minus 3. Negative 24 minus 3. And so I keep equaling this down, equals, oops. And so I know that h of 2 is equal to negative 27. So then obviously the integer ones are the easiest. It's the expression ones that are going to just be more tedious. So this x divided by 3. So So I'm just going to rewrite it because it didn't really keep that in it last time. So I'm plugging that x divided by 3 in for n. I need to cube this first before I can multiply that 3. So this becomes x divided by 27. I then have this negative, oops, what did I forget? The cubed. X cubed divided by 27. So then I'm going to actually simplify this negative 3 divided by 27, which is negative 1/9. So it's negative x cubed over 9 minus 3. That minus 3 is just getting tagged on there the whole time. And that's our final answer. This can also go at the end here if I didn't want to scrunch this in. All right, so just function notation there. Now let's look at something that maybe you've seen or not, a piecewise function. It's what it is. As we say it, it's pieces of functions. So a function that is defined using 2 or more equations on different intervals of the domain. So we're going to find each value given this piecewise function. So I'll highlight these maybe in different colors, is that this one is all of this guy, right? And then this one is all of this. Like you see, my spacing in there is not so great. I think it's better on your piece of paper. But the spacing in here, right? We use this equation if the x value is between these two numbers. That's kind of how that works. Okay, and then lastly, we'll just change this up. This one goes with this. So we're going to evaluate these separately and go to the piece of the function and where it's satisfied in the domain. So this is our x value of 72. So where does 72 fit into these pieces? It fits into this guy right here, right? 72 is greater than 68. So I'm going to plug it into that orange one. Maybe I'll use an orange just to 2. That's not really orange. So 2 times 72 minus 6 is 138. So h of 72 is 138. All right, now we'll go to 65. Oops. 65 here. 65 fits into this guy, it looks like. So I will use the green, right? 65. So 1.6 times 65 minus 41.6. So I'll definitely have to use my calculator for that one. 1.6 times 65 is 41.6. And it looks like h of 65 is equal to 62.4. All right, last one, the 68. You see that this guy here, it says x is less than or equal to 68. So 68 will be plugged into that second one. 3 times 68 minus 132. So 3 times 68 minus 132. So my h of 68 is 72. All right. We'll kind of keep moving here, just looking at piecewise functions that are graphed already for us. So this one, it was explicitly tells us the functions and the pieces. This one, I just have it graphed in pieces. So we're actually going to go to this last one here first and then go back to that one. So, and I changed E here, made that a 4. I don't know why I didn't have that different. But let's start here. Use the graph for the piecewise function f of x to estimate the indicated function values. So really I'm finding x and y values in this graph. So there's tons of ordered pairs. Let's see. So this guy here is when x is 0, what is my function? So what is y? So if x is 0 here, this point right here is 0, 2. So my y value there is 2, right? So again, if it says f of, it's saying f of x, that is x, is -3. So let me find where x is -3. Here it is on the graph. And then I go to where I go up or down to get my y value. Well, this guy is an open circle, so that doesn't give me anything. So I got to use this guy right here, which is -3, comma, -1. So my y value there is -1. Going to erase these. All right. Try that one. X is equal to 2. Can't use the open circle. Got to use the other one, so it's 4. All right, now backwards here. It says when f of x is equal to 0, so that means when y is equal to 0, what is x? So here's when y is equal to 0. I got this point, I got this point, and I got this point, all right there. All those points have the y value of 0. I can't use this guy because it is open. So then I got to use this guy here and this guy here. So it looks like I have -2 is when f of x is 0, and also at -4. Okay, so it's going backwards. Erase that. We can kind of see that still. If I were to get these points right here, this would be -2, 0. So f of x equals 0 there. And this one here, -4, 0. All right. And then we'll do this last one here. For this graph, looks like f of x is equal to 4. So I'm going to erase this to help me see that 4. So we got, this is when y is 4 right there, right? So let's go hit our graph. It's right there, right here, and right here are all where my f of x is equal to 4. So what is the x value when f of x is equal to 4? Here I have 4, 4. Here I have 2, 4. And here I have -6, 4. So I'm not asking you to write all those points out. I'm doing it to be helpful to see that my f of x is 4 in all those points. So -6, 2, and 4 are my x values when my function is 4. So that one's a little bit more in depth, but I needed to do that one before I think going backwards on this guy here. So go ahead and try f of -2. So what is my y value when x is -2? Looks like it's -4. F of 7. So when my x value is 7, what is my y value? Looks like +4. When my x value is 0, that's right here. So it looks like I have a y value right there of 0. And then finally, going backwards, this is when y is equal to 0. What is x? I'm sorry, when y is equal to 1. What is x? So can't use this guy, but I got to use this guy. It looks like x is 6. All right, very good. You have homework on formative, all right? Maybe some of you already started in the midst of the lesson. Hopefully not. All right, have a good rest of your day.